We're going to discuss the properties of exponents. So right here we have kind of the most common properties we use when dealing with exponents. And before we get into using these, let's take a minute to go ahead and try to justify each of these. So algebraically or in words. So we won't call these proofs because they're not really proofs, but sort of let's take a second to understand like why this is true, right? And the reason we want to do this is if you just try to memorize all these laws without really thinking about them, that's how you get them mixed up in your head. And if you take a second to justify why each one of these is true, then it's impossible to get them mixed up because there's only one way that makes sense. So, for example, something like this. When we multiply two numbers that have the same base, we can add the exponents together. And to illustrate this, let's look at a simple example. So suppose we had x squared times x to the third. So to square a number means to have two of them multiplied by two of them multiplied together. So that's x times x, right? Would be x squared. And then we're multiplying this by x cubed, which would be three of them times x times x. So these three would make up x cubed. So altogether we have 1, 2, 3, 4, 5 x's multiplied together, which would mean we have x to the fifth power. So division, we have a similar rule. So when we divide two numbers with the same base, we subtract their exponents. And again, let's think of a simple example why this is true. So let's suppose we had x to the fourth divided by x to the third. So x to the fourth, again, means we have four x's all multiplied together. And then x to the third means we have three of them. And we can see here that we have common factors that would divide out. So we have 1, 2, 3 pairs of x's that would divide to 1. So then we're just left with x to the first power, which would, of course, just be x. So an application of this quotient of powers is this zero power law. So this is one that people mix up a lot because they see x to the power of 0. A lot of people want to write 0 here. But the reason it's 1 is, again, we're going to use this quotient of powers rule. So let's suppose we had even just x squared divided by x squared. Well, we know from the previous example that this would be x to the power of 2 minus 2. So that's x to the 0. And we can also see x squared divided by x squared is a number divided by itself. So that should also equal 1. So that means that x to the 0 is going to equal 1. So having an exponent of 0 is equivalent to dividing a number by itself. And then we take it one step further. So if we have negative exponents, so let's take that quotient of powers rule again, and suppose now we had, let's suppose we had x to the negative 3. So that would be like the same as having x to the power of 1 minus 4, right? And we know that subtracting them means that the exponents could be, or the bases are divided. So this is the same as x divided by x to the fourth. And we know that if I expand this, then I would get x on the top and then 4 x's on the bottom. one pair of them is going to cancel out, and now I'm left with 3x's in the denominator. So that's the same as 1 divided by x to the third. So we can see that having a negative exponent, so x to the power of negative 3 is saying that we're going to divide by x 3 times rather than multiply x by itself 3 times. So now we've got power of a power. So this is x to the a to the b. Well, let's think about what this is, and let's just use 2 and 3 as examples. So x squared to the third power. So this is saying power of a power means we multiply the two exponents together. So x squared to the third power would mean that I have x squared times itself 3 times. And we can see here, now we can apply that addition property and see that that's x to the 6th. So we had 2 added together 3 times. So that's the same as x to the power of 2 times 3. And then the power of a product. So this is the one where it's kind of like the exponent is distributing. So if you have something that's in parentheses being raised to an exponent, then the exponent gets applied to everything in the parentheses. Notice this has to be multiplied, right? If you have two things being added and they're raised to some exponent, then this property doesn't work because this is power of a product. Power of a sum would mean you have to expand it using distributive property. So again, like let's just say that our exponent was 2, right? So that would mean I have xy times xy. And then since when everything's multiplied together, the order doesn't matter, so I have 2 x's multiplied and 2 y's multiplied. And lastly, the power of a quotient. So this is a fraction being raised to an exponent. And then it says we can just apply the exponent individually to the numerator and denominator. Again, using an example exponent of 2. So that means xy times itself. And when you multiply fractions, you just multiply straight across. So this is x squared divided by y squared. So definitely take some time to familiarize yourself not just with the rules, but with understanding why the rules are true. Because like I said earlier, if you understand the why behind these rules, then you don't mix them up because you'll always use what makes sense. So it wouldn't make sense to say that a power of a power is you add them because we just demonstrated here why it's multiplying, right? So now let's go into a few examples of using these properties. Problems like this can look a little bit intimidating at first, but the key here is to just kind of approach them one step at a time. So I've got a 6y to the 8th in the numerator, and then all this stuff in the denominator. So usually when I deal with these problems, first I simplify the numerator, and then I simplify the denominator as much as I can. Then I worry about all of the division, right? So numerator can't be simplified. So let's just simplify the denominator. 7 times 3. So 7 times 3 is 21. And I have x to the 4th and x to the 4th. So I'm going to end up with x to the 8th. And then I have y to the 4th times y squared. That's going to give me y to the 6th. And now I'll worry about simplifying. So I have the denominator is completely simplified, so now I'll worry about simplifying the whole thing. So first of all, the fraction 6 over 21 could be simplified to, we can divide a 3 out, and we would get 2 in the numerator and a 7 in the denominator. There's no other x's in this problem, so x to the 8th in the denominator will just stay there. And y to the 8th divided by y to the 6th would be a y squared. And since the 8 is bigger than the 6, then that y squared is going to go in the numerator. And that's it. So this is now as simplified as it'll get. So looking at number 2, we have a little bit more going on here because we have in the denominator another exponent that's being applied to both of these. So this fourth power here, before I do any simplifying from numerator to denominator, I have to deal with the parent exponent of the denominator, I suppose. So numerator will stay the same for now. And then I'm going to apply that exponent to everything in the parentheses. So a to the fourth power would be a to the 16th. And b to the 5th to the 4th power will be b to the 20th. And now we can simplify from the numerator to the denominator. So I have a to the 5th in the numerator, a to the 10th in the denominator. So 5 minus 10 would be a negative 5. So that means I'm going to have a to the 5th in the denominator. And then b to the 3rd divided by b to the 20th would be, so 3 minus 20 would be a negative 17. So since it's negative, I'm going to put it in the denominator. B to the 17th. Now, since I have nothing left in the numerator, that doesn't mean it's blank. That means, so remember, all of these things we divided the whole numerator out to 1 when we simplified, right? Because we had 5 a's and 10 a's in the denominator, so 5 of them got divided to 1, and then the 3 b's got divided to 1. So we're left with 1 over a to the 5th times b to the 17th. All right, things get a little bit weirder here. So we've got this negative exponent here. We're not going to worry about that until later, right? So first, I'm just going to deal with this 2 here, right? So I'm going to square everything that's in the parentheses. So 2 squared is 4. X to the negative 4 squared. Again, multiply the exponents, don't square the 4. So that's going to be 4x to the negative 8th. And then y to the 3rd squared is y to the 6th. And now let's simplify denominator. So denominator, we just have 2x to the 4th, y cubed times y. So that's 2x to the 4th, and then y to the 4th. So we can simplify 4 divided by 2 is, we're going to be left with a 2 in the numerator. And then the x's, so we have x to the negative 8 divided by x to the 4th. So subtract the exponents. And I'm just going to leave it in the numerator for now. So negative 8 minus 4 is negative 12. And I'm just going to leave it up here for now. And then y to the 6th divided by y to the 4th, we have y squared in the numerator, because 6 minus 4 is a positive 2. Now, of course, the whole denominator simplified to 1. But we have this negative exponent, and we don't want a negative exponent in our final answer. So what we do is we're just going to move this whole x to the negative 12 term into the denominator, because x to the negative 12 is the same as 1 over x to the positive 12. So in the numerator, we're left with a 2y squared. And the denominator, we're left with x to the 12th. A common mistake I'll see is that people also want to move the 2 to the denominator. But the 2 stays where it is because 2 is not being raised to the negative 12th. Only x is, right? That exponent is only on x. So 2 stays where it is, x goes down. All right, last one, because here we combine all of the rules, I think. So we have 2v squared, all raised to the negative 1. So let's apply that negative 1 to everything. So 2 to the negative 1, and then v to the negative 2. I apologize for using u's and v's in this problem. I tried to avoid that. And then the denominator we have is going to simplify to, so I have u cubed and u squared, so that's u to the 5th. And v squared times v to the negative 2 is v to the negative 4th. Oh, just kidding. That's 2 plus negative 2 is going to be 0. And v to the 0, I'll go ahead and write that 0. But remember, v to the 0, we know is 1. So let's move the 2 to the denominator, so because that's raised to the negative 1. So now we have, and let's move the v to the negative 2 to the denominator. So in the numerator, we're left with a 1. And in the denominator, we have, that's u to the 5th. And then, remember, v to the 0 was 1, so then we just have, we move the v to the negative 2 down, and we have 1 over u to the 5th times v squared. So go ahead and work on these 4 practice problems on your own. And remember to make sure you're looking at those properties and make sure you're understanding the properties and not just trying to apply them blindly.